Okay, 5.1b. So um, when we look at two variables that are associated with each other, we often want to know which variable could cause the other variable. And sometimes there's an obvious A could cause B. And sometimes we're like, well, A could cause B, but if you think about it, B could cause A. And sometimes it doesn't appear that A and B have anything to do with each other. They just sort of associate, even though there's no causation. Now, we're going to talk a lot about the difference between association and causation, and that's not what we're worried about today. So we're not actually worried about does A cause B. We just want to look at a situation and determine which direction does that arrow go? Or could it go either direction, or is there no arrow at all? Okay, so we'll do the first couple for examples. So variable 1, we study student test scores, and variable 2, we study the time that students spend studying. So which one do we think would cause the other to change? So this one could go either way. Traditionally, we would probably say the more you study, the better your test score, right? But there could be a confounding variable, right? I Oh, Garrett, you're here.
I
Oh,
am here.
they want me to give you a tardy. I've never actually taken roll for you. So, do they? Does somebody take roll for this period?
Nance does.
Oh, okay,
Yes.
okay. She's on it.
Yeah.
All right. So number one, we would probably say that studying is the I forgot the words they use. The explanatory variable, and student test scores would be the response variable. So the research question would be, how does study time influence test scores? So the explanatory variable would be study time, and the response variable would be test scores. Okay. Now, what's a possible confounding variable? What is a third variable that might influence both? Homework, how much sleep you get, whether you have a job or not, because having a job would mean less time studying, which might cause lower test scores. So it's not actually the studying that's the problem, it's that. So, because I am uber lazy on the answers, I just put response is the first variable and explanatory is the second variable, and then maybe it actually goes the other direction and students who test well study more. So maybe it does go in the opposite direction. That's not really a confounding variable though. So a confounding variable would be more like amount of sleep, um, maybe social economic status, the type of classes you have, lots of other things. Okay. All right, number 2. Oh, does that show up again? Oh, 24 is the same as number 2. So, okay, shoe size and reading level. Does shoe size cause you to read better, or does reading level cause you to change your shoe size? Neither. That one is neither. What's a confounding variable? Age. The older you are, the more likely your reading level and your shoe size are to go up. Okay? 3. Number of states in the US visited compared with enjoyment found in traveling. So does visiting more states make you want to travel, or does traveling make you want to visit more states? It could go either direction, right? Why? You think because you're on crutches, you can be late? That's what they said. And I said, oh, good. Birthdays? I'll give him a tardy. Where were you? Oh, all right. So, what could be a confounding variable for number 3? Where you work, maybe your parents were in the military, something like that, right? All right, number 4, number of hours you sleep compared with daily energy level. Does daily energy level cause you to sleep more, or does sleeping more give you more energy? David just wants to say both every time. And maybe. We would probably say traditionally that energy is affected by sleep. So sleep would be the explanatory and daily energy would be the response. Now, if you disagree, that's fine with me. I don't care. So the answers on the back are just kind of what I thought makes the most sense. If you have a good argument otherwise, that's fine. I'm totally cool with that. There are answers, you just didn't get them. So, you need to go through the rest, and at the end, there are 3 questions. Think of a set of variables that meet the qualifications below. You are not allowed to use any of the variables already used on this worksheet or the person next to you. You need to come up with your own. And there are 3 sets you need to create. 2 associated variables where an increase in one is suspected to cause a decrease in the other. Here's one you can't use. The number of times you get hit on the head with a hammer. And how well you do on a quiz. As the number of hits goes up, your performance on the quiz goes down. You can't use that one. So you can't use any of the variables. So you couldn't use hammer hits and you couldn't use score on a quiz. And then 26, 2 associated variables where an increase in one is suspected to cause an increase in the other. And then 27, 2 variables that are correlated, but instead of one causing the other, a third confounding variable causes both, and you have to list the confounding variable. All right. Okay, I will just put, to save on paper, let me get them all. There you go. All right, get to work. If you get finished and you want an early start on 5.1 practice, that's what we're going to do tomorrow. Go for it.